Hello everybody, this is Shane Beatty, and I just want to give you a little tutorial on this nifty little program that I wrote. It's called Circuit Expansion, and I wrote it to give people an intuitive understanding of what happens when electrodes expand and contract during lithiation and delithiation. So when you start the program, you get this screen. It has the instructions on the front. I'm not going to read them to you because everyone can read, so I'm going to show you what the program actually does. And make sure you read the instructions before you start, because after you click like this, they go away. So the easiest thing to do is just add some balls. This is a ball. You can hold down the left click button and move it around. You can throw it, and it moves. You see how it slows down. It's because I have friction on. If I turn friction off, it'll just bounce all around. I can keep adding balls in random places, and they'll bump into each other, and then it's kind of fun, big game baseball. So it's neat. It's not why I wrote this. You can hit the stop button to stop everybody, and you hit the remove balls button, and everyone goes away. What I typically do instead of just adding random balls is I add things like a line of balls. So when you add this line, you can move them around, perturb them, stop them, and then if you hit this expansion button, you see it'll expand. So you see this guy gets pushed up above. There's no room for him down his bottom layer. So if you had a one-layer electrode and you do this expansion, you're going to get significant particle rearrangement. So if you try to sneak a particle in here, then you have enough to move to accommodate him. And I added that ball just by holding your right button. The electrode will be whatever size you want. So when you add this line, it's based on this expansion value here, 270%. I chose that value because that's silicon at full lithiation. So that's all neat and fun. You can perturb them around. I typically leave friction on because I don't like them bouncing around so much. Instead of adding a line, you can add a matrix. Again, it's based on this expansion value here. So here I've added a matrix of particles, and I'm giving them enough space around each other to move. I was perturbing them a little just to see what I get. I hit the expansion value. You see they expand and they move. So they're trying to sort of find the lowest energy state. You see that eventually these guys are going to form this nice hexagonal structure. That's the highest packing density you can get for circles on a two-dimensional plane. So you can perturb it a little, and you see they're all kind of jiggling around, but now they're pretty happy. This is sort of their lowest energy state. And in addition to expanding the spheres, you can contract them. So this is a negative 270% expansion. So this is essentially what's happening in your electrode when you fully lithiate it. You contract it and you expand it. What's important to see here is the large amount of dead space required to accommodate this massive expansion. Here we're calculating the porosity. The porosity is very high when you start off your electrode to accommodate this expansion. And at full lithiation, you see the porosity all the way down to about 25%. This is a massive change in the volume of your electrode, and something you need to take into consideration when you're engineering it. So what else you can do is you can add in different particles. Like imagine your electrode actually isn't this nice array of perfectly sized spheres. Instead, you have different particle sizes. Now what happens when we try to expand these by 100%? You see they all move around. They try to find where they're supposed to be. And here we find out we don't have enough space. We have a bunch of overlapping stuff. So let's get rid of that. So instead of 270%, let's go down to, say, 100%. So now when I expand the spheres, there's lots of room. So I add in some other spheres just to keep things interesting. And I expand. So not too bad. They can handle that. But when you go up to higher expansions, say 200, now they have to move around. It's particle rearrangement. %. So what you can do is you can add in some particles. And what I like to do is turn on gravity. Consider this to be sort of like a binder. These things want to stick together. So with gravity on, when you add particles, they all like to be beside each other. Now, look what happens when you contract. So if you contract, now they all end up flying together and sticking together because they're attracted by gravity. And now when you expand again, notice how all the little guys end up agglomerating towards each other. And this is more pronounced the more you expand and contract. And this is considered to be agglomeration. This happens in real electrodes. So conceptually, you can see how sort of this happens if everyone wants to be stuck together, and these small guys end up, fitting in between these little spaces here. So that's very good, very interesting. Something else to be aware of is what happens if you change the expansion to a very small value. Something like 10%, so say carbon or graphite. When you add this matrix, there's very little space required in between. I'll turn gravity off. And when you expand, you see the very little particle rearrangement. Contract, expand, there's not a lot that goes on here. So imagine this is your carbon electrode. It doesn't have to accommodate a lot of particle expansion. Whereas if you're all the way up to 270%, this is what your electrode starts with, and then there's massive particle rearrangement. So the difference between graphite and silicon is significant. So in addition to what I've already showed you, you can do things like hit the F1 button and make the last sphere added bigger and smaller. So this guy, for example, if I press F1, it's bigger and move things around. F2 will make them smaller. If you want to make them all bigger and smaller, you hit F3 or F4. So this is sort of more of an incremental. So you can watch it sort of step by step, what happens and how they move and why they move, and things get pushed around. So you can do all kinds of neat things. I'll leave it at that. I'm sure you can have your own fun with this. You move things around, make the balance, do what you want. So it's great. If you have any questions, feel free to get hold of me.